Hello, all of you. Now, today I'm here with the boiler burner part 2 video. As described earlier, the pressure jet burner was discussed. Now, I will discuss about the boiler burner rotary cup type. And in this one, the design, the working principle, and some maintenance also discussed. So rotating cup fuel oil burner, it consists of a tapered cup. The tapered cup is attached to the central rotating spindle. And this spindle is basically mounted on the ball or roller bearing. And due to this, what happened? The cup is also rotating with a high speed, and the fuel oil is supplied to the inner surface of the cup through the hollow end of the spindle. And what will happen? This created a centrifugal force because of the rotation. So, large centrifugal force is created and it allows it to spread into a thin film. And then what happens? It moves along with the tapered part of it and it reaches to the tip of the cup. And the radial component of the velocity at that moment causes it to break up into the fine particles, and then it comes out as a hollow rotating cone of the fuel, which is finally atomized. So whatever I have described, just I can show you with the help of laser pointer. As you can see here, this is the fuel oil supply line. Okay, you can see here, and this is your the spindle which is attached with the belt drive or the gear drive through an electrical motor, and this is the cone, the rotating cup which is attached to it, and you have a fan which supplies the air for the further automation and burning, and in this you can see primary atomizing air stream is coming out of it, and primary air inlet is this is the butterfly valve which basically gives you the control, means 0% to 100% as per the requirement when pre-purging, post-purging, and the fuel automation, means as per the demand the butterfly valves work, and it allows the amount of the air which is required for the combustion. Here which we talked about the bearings, these are the bearings on which this shaft is mounted. So these may be the ball bearing or roller bearing. So this is just a simple diagram. The further we will see the automation also, how the automation happen and how it works. The rotary cup fuel oil burner perform two functions. As we have seen, due to the rotation, centrifugal force is created. So it supplies the rotational energy to the oil. When you can see this supplying the rotational energy to the oil. And due to this energy, the oil break up into the fine particles. So this is nothing but automation part. Okay. And at the result, what happens? Due to this, a hollow rotating cone of oil droplet is leaving the burner. So these are the two prime functions performed by the burner. Here you can see whatever we have discussed in a more elaborative manner. So the red color one is basically your fuel oil part, and the light blue is your the air part, from where the air, here you can see primary air passing through this part of it, and as we have seen earlier, the secondary air is from there. I will make one video also regarding the combustion of the fuel in the boiler burner part of it. So how primary air, how the secondary air, and how tertiary air works. So that video I will also make for you guys. Okay. And this yellow color part is the rotational part. It's having the rotation. So whenever the fuel is coming out of it, out of this tip, and this makes a thin layer on this part of it. And due to the high rotational velocity, a centrifugal force gives the rotational energy, and it just give the automation energy, and it when the fuel leaves this cup part, as you can see over here, it is having the uh, automation also. So this is the complete structure. As you can see, the actual rotating cup burner part also, and here you can see the automation of fuel also happening. In the pictorial representation, you can see over here the fuel goes out of it, fuel distribution manifold, and through that when it comes out, here you can see the yellowish part. This is the fuel part, and that's how you can see the atomized fuel which is coming out of the rotary cup burner part of it. And here is a fan which provides the secondary air also, and the primary air is being controlled by the flap, and flap, as per the load requirement, it changes the flow of air. So rotary cup burner pressure requirement. How is the pressure requirement? Pressure requirement, as we have seen in the pressure jet burner, high fuel pressure is required, but here it is not required. This pressure is not required because it is not required for the automation of the fuel. Automation of the fuel is done by the centrifugal force. The fuel oil pressure is to be just sufficient. The requirement is that it should be just sufficient to overcome the frictional resistance of fuel oil through the pipes. So 3 to 5 kg is enough, and the fuel has to have the viscosity as well as the pressure balanced in such a way that it passes through the pipeline and goes to the rotary cup part of it, and then everything is being done by the rotational energy provided by the rotary cup burner. In this type of burner, we can use the gravity type of fuel oil supply system also, because it provides approximately 3 to 5 bar pressure. What is the throughput requirement? So as oil throughput is controlled by the regulating valve in the fuel oil line, which we have seen. So in this type of burner is having wide turn down ratio. Turn down ratio I have already explained in the earlier video, 10 is to 1. So we have a lot of control in this. The diameter of the cup must be large enough. When we design the cup, the diameter must be large enough to basically handle the large throughput, and there must be sufficient taper and rotational speed. So three factors very important. One is your the diameter of the cup, another one is your sufficient taper, and third one is your rotational speed. So these three things basically gives you the proper throughput. So the oil should attain the atomization velocity, and it gives the maximum throughput as required. For minimum throughput, when we talk about this, the just sufficient oil must be provided so that the fuel oil film must be formed inside the cup. So if the fuel oil film is being formed inside the cup, then of course rest of the thing will be done by the centrifugal force, which gives the rotational energy, and automation is being done. So maximum and minimum throughput also I have discussed. Next, rotary cup burner air supply. As we have seen the primary and secondary air part also. So in the smaller units, all the combustion air supply is through the burner itself, and air supplied through the space between the rotational cup and fixing casing. Okay. In other cases, only primary air is supplied in this manner, which is utilized for the automation. Primary air is basically utilized for the automation part of it. Only 10% of air is supplied as a primary air, other all are supplied through the secondary air part for the larger units. Okay. Here you can see some of the advantages of rotary cup burner. This we have four columns: burner, automation, oil pressure, and fuel viscosity. So this rotary cup burner, the automation is done by the centrifugal power, which provides the high air pressure, and automation is done by that. The oil pressure is not required much, 3 to 5 kg per centimeter square is enough. And as per the requirement, as per the throughput, it can increase also. And fuel viscosity, wide range of viscosity can be handled over this. But when we talk about pressure jet burner, automation is done by oil pressure, because at the name itself implies pressure jet burner. uh, high pressure fuel oil requirement is there up to 20 kg per centimeter square. So in pressure jet burner, we have seen already 7 to 10 kg is there, and it can handle the limited range of viscosity. We have to maintain the temperature also about 110 in case of heavy fuel oil, uh, high sulfur content heavy fuel oil earlier, which we have worked. So this is having limited range of viscosity. So the versatility with the rotary cup, it is capable of handling the wide range of viscosity also, and this can be maintained by the temperature control. So these are some of the advantages which we have already discussed. Now we will go for the some maintenance part of it, general common maintenance, which is to be taken care of. So rotary cup. When we talk about rotary cup, the clean and hard deposits, basically when we do the maintenance of it, so the inner surface of the cup should be cleaned thoroughly. Sludge buildup can be causing the misalignment, and the proper automation will not happen. So the inner side of the cup should be cleaned for any hard deposits. Atomizer, clean with a paraffin to lose the deposits. So never create the scratch marks inside it. With the in our ship engine room, the diesel oil is there, and we can dip it into it so that the hard deposits will be softened out, and then it can be removed. With the soft metal scraper, we can remove it. Inspect the surface for the damages. Clean all the holes. Replace the o-rings if it is there and required for any atomizer which is being removed. Then combustion chamber. Clean should deposits debris, and the chamber should ensure the well sealed part of it. So this is a general understanding of it. Any combustion chamber has to be a clean one. Rotating parts, because as it is rotating, we have to be very careful about the vibrations, abnormal noise, and the condition of bearing. Whatever is the lubrication required for the rotating parts must be done. What about the fan and the air passages? Fan and the air passages, this fan inlet, burner resistor, air passages must be cleaned for any obstructions, dust, and deposits. This is a very common part. Continuous use can create all these obstructions and dust deposits, so it must be checked and cleaned. Oil passages, oil passages should be cleaned for any heavy oil deposits. In that one, the filter and all whatever is there, it has to be cleaned time to time basis. Otherwise it can restrict the flow, and it can create the problem for the desired throughput. Flame stabilizer, inspect and clean the carbon deposits. Check the stabilizer for heat and corrosion. That is also, when you are doing the maintenance, proper investigation is required. Heat exchanger and pipes, that is a very common part. Uh, this has to be thoroughly investigated, checked, and drain trap, monthly cleaning, fixing piping annually if it is a piping heater. So if you have the steam tracing line and all these things, so basically the heat exchange part has to be thoroughly inspected and cleaned. Electrical checks. Connections for any leaks, tighten all the connections and ensure all fixing screws are tight. Inspect for the condition of wiring also. Whatever the wiring conditions, that must be inspected. Solenoid valve. Verify the solenoid valve for main burner and check that for the correct working part of it. And check for leaks at this connection. If any leakages throughout the fuel line, any leakages must be rectified. Belt conditions, 50 to 100 hours must be checked, and if required, retensioning, readjusting is required, done. Or if the condition of belt goes worse, then need replacement. Sensors, all the sensors for correct operations must be checked, and the pressure switches, thermostats, that also condition is to be checked, and ensure the trip limit when the burner door is opened, then the trip switch must be activated. So that functionality also must be checked. Okay, so thank you all of you as I have tried my level best to make you guys understand about the rotary cup burner functionality and some of the maintenance of it. So in next coming video, I will come up with the boiler combustion part, how the combustion happens basically. Thank you.